So this video will have several examples that will look at simplifying with trig functions and identities and equations and formulas. So we're going to start off with an expression where we have 1 over 1 minus the sine of theta plus 1 over 1 plus the sine of theta. And you can look at your identity page and your equations and your formulas, and you don't have sine squared. The denominators have quantities in them, so you can't rewrite them as anything just yet. So for this one, we'll simply start with the fact that we're adding fractions and we need to have common denominators. So to do that, they have nothing in common. One's a 1 minus sign, one's a 1 plus sign. So we're going to take that and we're just going to multiply each side by the other denominator. So the left fraction will get multiplied by 1 plus sine theta over 1 plus sine theta. And the right fraction will get multiplied by 1 minus sine theta over 1 minus sine theta. All right. So then what we have for this problem is we'll end up, the numerators are just multiplied by 1. So our numerator on the left is just 1 plus sine theta over 1 plus sine theta 1 minus sine theta. I'm not going to FOIL those out in the denominator because I don't know if it'll help me yet or not, so I'd like to clean the top up before I do that. The numerator on the second fraction is 1 minus sine theta. The denominator is again 1 plus sine times 1 minus sine. Now that I have a common denominator, I'm simply going to add across the top, and it's addition, so I don't have to worry about distribution of a subtraction or anything in that manner. So my numerator is 1 plus the sine of theta plus 1 minus the sine of theta over a common denominator of 1 plus sine times 1 minus sine. My numerator will clean up in the fact that positive sine theta minus sine theta adds to 0. I'm left with 1 plus 1 in the numerator, which is 2. And in the denominator, now that I have a 2 up top, I'd like to look and see if I can do anything with the denominator. So you'll notice that they're the same quantity, 1 plus 1 minus, and it's actually the factored form for a difference of squares. Factored form. And if you FOIL that out, your outer and your inner terms cancel, and you just have 1 minus sine squared of theta. And if you go to your identities, your trig identities, you have the identity that sine squared plus cosine squared equals 1. And you can rewrite those in terms of sine or cosine in that cosine squared is 1 minus sine squared, which is exactly what we have going on in this picture. We have 1 minus sine squared, so I'm going to replace that with cosine squared, 2 over cosine squared theta, and I can't simplify the cosine squared any further. So one potential answer is 2 over cosine squared theta, or you could take this one step further because if you recall, 1 over cosine is the same as secant of theta. So 1 over cosine squared will be the same as secant squared of theta, and we could make this 2 times secant squared of theta, and both of those would be acceptable answers for this problem. Okay. All right, next example has sine of 2 alpha over cosine of alpha. So this one doesn't involve any squares, but the numerator does involve a double angle formula for sine. So based on our identity sheet, or formulas, we have that sine of twice an angle could be replaced with 2 times the sine of the angle times cosine of the angle. And we divide that by cosine of the angle. And the numerator is a product of things, and the denominator is a single cosine. So we are allowed, because it's a product, there's no addition or subtraction in the numerator, to cancel out and divide away the cosines, and we are left with 2 sine of alpha for our final simplified answer. So that one's not too bad. All right, next question has us simplify 2 fractions with subtraction. Now, while you could, the denominators have nothing in common. One has sine times cosine, the other has a tangent, and they have nothing in common. And it would get really messy, potentially, if you just gave each other fractions. So the fact that I have a sine and a cosine and I have a tangent, I'd like to think of tangent as being sine over cosine. Or maybe you'll notice the fact that 1 over tangent is the same as cotangent. And cotangent is cosine over sine. And again, if we have 1 over the fraction sine over cosine, that would be 1 times cosine over sine. So either way, we end up with the second fraction being minus cosine of t over sine of t. And our first fraction is 1 over sine of t times cosine of t. So now, notice we have almost the same denominator to be able to subtract across. But I need an additional factor of cosine of t multiplied cosine of t to the numerator and denominator to the right fraction so that I have my common denominator of sine t cosine t. So I have 1 over sine t cosine t minus cosine squared over sine times cosine. I have a common denominator now, so I can simply subtract across the top. The numerator is 1 minus cosine squared of t over sine t times cosine t. The 1 minus cosine squared t is actually a form of the trig identity, the Pythagorean identity, right? We had cosine squared plus sine squared equals 1. And if I rewrote that in terms of sine squared, I'd have that equaled 1 minus cosine squared, which is exactly what I have in the numerator. So I'm going to simply replace 1 minus cosine squared with a sine squared, not of theta though. Watch the variables. Sine squared of t over sine of t cosine of t. And another thing to keep in mind, the sine squared is the same as the sine function actually squared, which is just sine times sine. So I can cancel one of those sine functions up top with one on the bottom. That gives me sine of t over cosine of t, and sine divided by cosine is tangent. So our final simplified answer is just tangent of t. So that worked out quite nice. All right, next example has the addition of two fractions that have no common denominator. Nothing is squared, so I can't really use an identity or a formula to replace. And then I have over here on the left or the right fraction, my denominator has a sum in it, so I can't split apart fractions and try to simplify. So I'm just going to attack this one with the fact that I'm adding fractions and I need common denominators. So I'll multiply the left fraction by cosine theta plus 1 times cosine theta plus 1, and I'll multiply the right fraction times sine theta over sine theta. So again, we're not changing anything. We are validly multiplying to get common denominators and not changing the value. We're just changing its visual representation. So when I do that, my common denominator becomes cosine theta plus 1 times sine. I'm not going to distribute that because it may benefit me to have them factored. And it may not. We'll just have to see. When I distribute on the left fraction, I have cosine square theta minus, actually I probably have to FOIL on that one, right? So it's cosine plus 1, cosine minus 1. Those end up, oh, where'd my thing go? Here we go. Cosine squared, and then minus cosine plus cosine, and then minus 1 plus sine squared. Just sine times sine is sine squared, and I have a plus in the middle. No need to worry about distribution of a negative because it's positive. Notice in the numerator, there's a cosine squared plus a sine squared, and that is the Pythagorean identity in that cosine squared plus sine squared of an angle equals 1. So those two terms would replace with a 1, and my numerator would then have 1 minus 1, and the denominator cosine plus 1 times sine. But what happens in the numerator is you get 0 over cosine theta plus 1 times sine, and that is going to give you an answer of 0 for your final answer for that one. So that one kind of cleaned up and canceled out completely. All right, next one, cosine squared minus 1 over sine squared. So looking through your trig identity sheet, there are several things that involve cosine squared. There's a double angle formula that says cosine of 2 theta is 2 cosine squared minus 1, but I don't have that 2, so that's not helpful. Anything else that has a cosine squared also has a sine squared, so I don't think that would help me. There's a sine in the numerator. The other identity that I have is that cosine squared plus sine squared equals 1. And if I write that in terms of sine squared is 1 minus cosine squared, notice that's almost the same quantity that I have in my numerator, but the subtraction is flipped. And we could write that with flipping the subtraction, but as we've talked about before, you'd have to take a negative and factor that out, and then that would allow you to rewrite that as cosine squared minus 1, and then the negative that you factored out, you could bring it over to the sine, and you would have negative sine squared theta equals cosine squared theta minus 1, which is what we were trying to replace. So we'll replace cosine squared theta minus 1 with negative sine squared theta, and that gets divided by the sine of theta. And again, sine squared is like sine times sine, so I can cancel one of the signs up top with the sign on the bottom, and my answer is negative sine of theta for the final simplified answer. So it used the Pythagorean identity of cosine squared plus sine squared is 1, rewrote it in terms of sine squared, and then we manipulated the order of the difference by factoring out a negative, which again is a valid thing that you can do in math. All right, next one. I've got a double angle for cosine divided by cosine of t plus sine of t. So I need to go and look at my cosine double angle formulas. And those were 2 cosine squared of the angle minus 1, or 1 minus 2 sine squared of the angle, or cosine squared of the angle minus sine squared of the angle. Now my denominator has a cosine and a sine. And my first option only has a cosine. My second option only has a sine. But my third option actually has a cosine and a sine. And if you'll notice, that's actually a difference of squares that will factor into cosine plus sine and cosine minus sine, which just so happens to match a quantity in the denominator. So choosing that third form of cosine of 2 theta will benefit me the best in trying to simplify this equation. Again, the first two, if I do 2 cosine squared minus 1, it won't factor. I don't have anything to simplify. And the second one also, it won't factor because of the 2 as the coefficient. So if I replace cosine of 2t with cosine squared, let's use a t here, minus sine squared of t over cosine t plus sine t. Again, remember that numerator factors into cosine, it's the difference of squares, so cosine of t plus sine of t and cosine of t minus the sine of t all over cosine of t plus sine of t. There's a whole lot of addition and subtraction going on here, but the fact that we have common factors, this cosine plus sine in the numerator and the denominator, those will divide to 1, and you're simply left with the cosine of t minus the sine of t. And you're subtracting two functions that won't, that is simplified. There's nothing to combine, there's nothing to rewrite. So your final answer is cosine of t plus or minus sine of t. All right. So several examples using double angle formulas, using Pythagorean identity, using some trig relationships that we've learned, and then simplifying again. Trying to get to where you need to stop will be, you can't simplify any further, don't undo something you've already done, and choose the substitution that would benefit you the most for what you're trying to accomplish.